everyone, welcome to today's presentation, Speed Up Your Development with Metadata-Based ETL Processes with the great Bernhard Engleder. I know I messed that one up. I'm trying. Get it right next time. That's my promise. Dang it. All right, as always, this is the Cloud Data-Driven Online User Group. As I said, it's to speed up your development with metadata-based ETL processes. Today is January 11th, 2024. As always, thank you for attending our webinar today. Please make sure to follow us on many of the social media platforms. Be sure to share this meetup group with your friends and peers. And as always, this session is being recorded. The board organizers for 2023 for the data-driven group are Jean-Joseph, Ronan Ariel, and myself, Kevin Wilkie. Always connect to us in many of our various platforms and ways. We're all out there some way, some form, some fashion. As always, there are some fairly short rules to go through for each of our meetings. Be sure to comment with respect in the chat window as you're going through. No offensive comments. Pretty easy. Be sure to turn off your video and microphone. I'll be turning mine off so we can focus on Bernhard as he goes through his presentation. And be sure to type your questions into the chat window. I'll be monitoring that so I can feed them over to Bernhard as we go through, or we'll wait through the very end depending on how time goes through. As always, be sure to connect with us on the social media platforms. Some of the future events that are coming up that pertain to different things in BI and whatnot that we cover in this group. As pretty soon there is the Atlanta BI near us and near me in Atlanta, Georgia, on February 10th. There's also one coming up on March 9th in Austin, Texas. Be sure to go to that or many of the other SQL Saturdays and various events that are near you. I put the webpage for both of those out there in case you would like to go to each one of those. Also, be sure to visit our data community for any of the latest updates on datadrivencommunity.com, datasaturdays.com, sqlsaturday.com, or meetup.com itself. And be sure to go to Microsoft Learning because there's a lot of great information out there as well on various things, not just on SQL Saturday, or on SQL Server, but on Power BI, Fabric, you name it. If Microsoft has anything to do with it, it's out there and it's all good. Some of our future presentations that we'll be doing here in the next few weeks: 3 types of low-code Power BI Microsoft Fabric extensions with Power Apps with John on Thursday, January 18th. And on January 25th, we'll have Ed Pollock doing columnar data storage, a deep dive into Parquet, Delta Parquet, and column store indexes. That looks like fun. If you would like to present any session, please email us at jeanjoseph@bigdatadriven.org, and we'll get right back to you on some of the ways to present and get this moving and grooving. As I said earlier, today's presentation is Speed Up Your Development with Metadata-Based ETL Processes with Bernhard Engleder. And as a very, very small thing, his bio is data enthusiast. And so with that, Bernhard, over to you.
Thank you. Thank you, Kevin. Just get sharing. And let's start. So, welcome, hi, or as we say in Austria, where I'm located, Servus. My name is Bernhard Engleder. I'm a data consultant at ACP CUBIDO, which is a small consulting company in Austria based in Linz. And I'm, as I said, data consultant, and also I'm the team leader of the data and AI team there. So before we go into metadata-based ETL processes, I want to take maybe a look back into the past. So maybe pictures like this look familiar to you, and I may or may not be somehow guilty for solutions like that in the past. So I didn't know it better 10 years ago. So maybe know it, old SSIS packages with multiple data flows. Some of them already have kind of alert sign on that, so maybe outdated or some problems occurred. Or also in the last years when all the cloud tools and ETL, cloud ETL tools occurs like EDF or Synapse and so on, we also had some solutions where we do multiple data loads for one data load per table, or different types of tables, and we do it on and on and on and on again. The same task for a different table results into solutions like that, where we load different data into our staging area, our data warehouses, and do further data processing. So, as I said, for those data loads, for the staging steps, loading our tables from the source system to our data warehouse database, we created many data flows manually. So this results, of course, in solutions like you've seen before, into many data sets and pipelines in your SSS package, in your ADF pipelines, and so on. But yeah, I guess you know it. What is the problem, or what are the side effects of those, let's call it hard-coded ETL pipelines and ETL processes? At the beginning, maybe the solution is quite small, and you know what this is doing, and the maintenance effort isn't that big. But as we all know, those solutions grow and grow, and also the maintenance effort for that solutions grows, and it gets quite high at the end. As those solutions are growing, the more they're growing, the more you are missing your overview, losing your overview, and have a lack of clarity regarding those solutions. Also, when it comes to schema changes, when your data sources are changing, new columns are changing, column are being removed, this also causes problems and requires your adaptation to the solution when a new column is added or is removed. One big problem, for example, when you want to add additional tables, there is no scaling at all. So when you want to add new tables from your data source into your data load, you have to do the same work, the same effort again and again for each additional table. And as we all know, when we're doing the same task over and over again, it's quite usual that sometimes an error occurs, or you're doing a mistake. So the error rate during the development is a big problem in those solutions. What is a solution for some of the problems? In my opinion, metadata is the key for automation and scaling in those data loads. So what is the idea behind that? You define and you maintain your information about your data loads in a central store, in a central metadata table, where you can maintain your information about your data sources, about your tables you want to load from A to B, and then use this information to automate your data loads. For this, there are at least two different approaches. My point of view, so on the one hand, you can build your own configuration tables in your data warehouse, in your configuration, and then use this information about your configuration, about your tables to automate your data load of multiple tables. And you can also generate source code on your data loads based on this metadata information. I'll show you some examples afterwards. A second approach is, instead of building this metadata-based ETL processes on your own in your solution, use some development tools, so some data warehouse development tools, which are also based on metadata. I can show you one example in this presentation. So let's start with the custom-made ETL processes based on metadata. In our Azure Data Factory, or also in Azure Synapse, there are some possibilities to do that. And to have a quick start, there are also templates available for this task. So on the one hand, there is the copy assistant, the metadata-driven copy task, which seems quite good for this task. And on the other hand, also in the gallery, there is something like called bulk copy from database, which is doing nearly the same. So yeah, maybe we should have a look on that in the Azure Synapse workspace. So when we start this, maybe right on the start screen, there is the copy data tool, and there is the mentioned metadata-driven copy task. So okay, let's start with this. Select a linked service. Where is our control table, or where should our control table be located? Just take the default table name for this example, click next, which source type we want to retrieve. Let's take the Azure SQL DB connection to our source DB. Well-known AdventureWorks database. Let's select all sales LT tables. Now you can configure the loading behavior behind for each table. For example, should it be a delta load or a full load? What should be the watermark for this delta load? But for that, we just skip that and take the full load. Okay, where should it be stored? What is our destination? Okay, there's a table mapping from source table name to target table name. You can adjust that, or take the default. And also define some column mappings, or add a pre-scope copy script, which is executed before the data load. Thing a name, summary, and Synapse is creating the data sets, the pipelines, and an SQL script for us. So this is the SQL script for the control table, which maybe looks not that easy at all. Got a few lines of code. Let's have a look on the pipeline, which was created. Actually, it wasn't not only one single pipeline, there were 3 pipelines. Okay. There is a lookup, there is a for each on another pipeline, and again for each on a third pipeline, which is wasn't that simple. I would expect when I call this assistant and this pipeline maybe isn't the best start to have a simple metadata-based pipeline. So maybe just skip that and go to the second example, which I mentioned, which was the bulk copy from database. Continue. Oh, that looks much more simple for our purpose. Again, called configure the linked services for the control table, for the data sets, for the data source, and our destination. Let's give it to our SQL Server. And now we have created one simple pipeline, which has a lookup task to retrieve the list of the tables we want to load, and then a for each task with just one activity, copy data from source to sink. So that looks much more we were expecting. And when we look at that in my demo first version, we have a lookup where we retrieving a simple data set from my control table, which is as simple as it can get: source schema, source object name, table name, and the same for the destination. I want to load all the sales LT tables from my source database from the AdventureWorks to my destination database with the same table names, but the schema is changed to AW, and C have let's run this. You can see when we switch to our database, which is the source, the destination database. I have my config tables, but not tables from AdventureWorks yet. So this lookup as an output, he gets 10 elements, all my tables from the configuration table, and then he loops through this result and copies for each table. And then we have here our tables from the AdventureWorks. Okay. So what is behind that? So in that for each loop, we are using this output of the lookup activity, and then we're using this informations which you get from the lookup in the copy data task for source schema, source object name, and destination schema and destination object name for the destination tables. Tables are all auto-created, so if they don't exist, they will be created in my destination database. Okay, quite simple. Next step, we already saw some of them. There are many possibilities for parameters in ADF or Synapse pipelines. So we already saw them for the copy data task. We can also use them or define them on pipeline level. We can use them for procedures for linked services, for example, to enhance our metadata-based pipelines. And for that, we can also enhance our configuration table. So the first version was quite simple, source and destination tables, but we can also maintain our informations about our environments. Is it a productive or a development or a Q&A system? We can define some scopes. Maybe we want to load different types of data on different times. For example, all my master data should be refreshed 2 times a day, and all the sales data should only be refreshed in the evening because there is a lot of data. We can define some selection lists. Maybe you only want to load specific columns and not all columns of one table. We can define business keys for example, to do automatic historization, or define conditions for a delta load. And for that, I'll show you in the next demo. We can put a lot more in our configuration table. So in this version, we have added some additional informations. For example, the selection list, where we define specific columns for a table, or a condition list where we can then have additional filters for the where clause. We have defined an active, inactive column, define the load type. If it's a delta load, then maybe define a load window in days where the modified date should just load me the data of the last 30 days from now. And also maybe do a historization for slowly changing dimensions for a specific table. In this case, the product master data should be historized by those columns. To based on that information, we can, or I created a few which handles those informations, and as a result, for example, we create our source query. So based on the information we defined before, we can define the source query to retrieve the data. For example, when you have defined your specific columns you want to retrieve, then it's based in also already in the query, and also the conditions and the conditions for delta load or the filters you have added are already in this query. So we can see here, which I didn't mention, is we've also added the environment or different sources, different source IDs. So it's not only the invention works, it's also maybe from our CM system. And we can use this for filtering to do different loads for our data warehouse. And go back to our query, our view, which is preparing all those informations for our delta load. So when we go back to we go back to our Synapse workspace and open the second edition of our metadata-based pipeline. And we see we have some additional parameters for the pipeline, which running the source system, the environment, and also the scope. And these parameters are used for our lookup. So pass the parameter values to our lookup and get me the right tables, the list of tables for this environment, for this scope. For example, I just want to load master data and which source systems should be retrieved. Again, all those informations are retrieved by the lookup, and we can pass them to our copy data task. Again, we already saw that in the first example, schema and table name are passed to the copy data task or the data set. But also in this case, server name and database name. So this is not a, let's have a look on the data set. So that's not fixed on a specific database. So for example, when you want to switch between development and productive system, then we can control that via the parameters. And so this data set is parameterized, and also linked service give them the information on which server, which database name we want to connect to load this data. So that's the connection to the data sets, and also the source query we saw before. This is the information, which data, which query should be executed to select the data we want to store in our sink. So again, table name, schema name, we already saw that. And we also added a pre-copy script, which does the truncation for our table if it already exists. If it's not existing, then it would be created by the auto-create table. Okay. Second version of our metadata-driven ETL pipeline. Okay, we saw our configuration table gets a little bit bigger with some more informations. We can also enhance our pipeline itself. So for now, it was quite simple with the lookup and the copy data task. In our ETL process, we have some different tasks to do, so we can add some more tasks in this pipeline. For example, we want to, before or after the copy task, we want to do additional tasks, add some logging, maybe some tasks for historization or the delta load. So we can put them into our pipeline and do those tasks based on the metadata. And second possibility, or was just quite nice, what we're using in our customer project is based on this metadata, on the informations about your tables. We can also generate source code based on this informations. So we can, for example, generate some procedures or statements for index creation, and we can use them on demand or automatically when we have this information in our pipeline. So can generate them. Maybe if there is a specific request for single table, hey, adapt those default procedures. But at the beginning, they're automatically created by the system, and we can use them automatically in our pipeline. So when we go to our third and last version of the pipeline, let's see what we have added. We have added some logging, and again, we have our lookup on the table list, and in this case, new version. Let's switch to the more enhanced view. We have some new columns for the statements I've mentioned. So let's have a look on that. We have after our source query, we have some information we can use during our in our pipelines. So information about the table names already with the schema name in the text, and we have some create statements or some statements to create the table in our operational data store, or create some clustered columns to index on this table, or create or execute or drop a procedure which is loading my data. So all the statements are already prepared in our view based on the metadata which I maintained in my control table. And when we have a look on our for each container where we copy or we loop over this result, then we have again our copy data task, which isn't that new, but we have also some additional script task we are executing. So maybe just when it's not available or created yet, then create my ODS table and create the column store index on that. And we're using the statement which is retrieved by the metadata view. And again, also creates load, the table is created, loads the ODS procedure, create the ODS procedure, load the ODS procedure, and do some historization. So additional tasks for our data load. And after that, some additional tasks, maybe automatically refresh some of your Power BI data sets, so semantic models as they call them now, and also some logging at the end. So as you can see, we have enhanced our pipeline. Still not that complex so you can easily understand what is happening. We can use it for multiple tables in a single pipeline, instead of creating all those logic and all those tasks for each table again and again and again. Okay, so to wrap it up for the first scenario, what are the advantages to use a metadata-based ETL pipeline in Azure Data Factory or Synapse, or wherever you want to implement those logic? You have a centralized administration of your configuration of the data loads. So you have a central place for your table names of what your steps you want to do in your data loads, and maintain this information in a central place. So one result of that is scaling. So it's quite easy to add new tables to your data load. So instead of implementing additional data loads to your pipeline, you don't have to touch your pipeline. You just have to add a new row, a new entry in your configuration table, and at the next execution, this table will be considered in your data load. You have also the possibility to react to schema changes automatically. So when we can check the columns during the data load, when it's some new columns arrive, or the data types have changed, or some columns have been removed, you can react automatically to those schema changes. One big advantage, and what we're it's one big reason we are using those metadata-based ETL pipelines, is you can reuse a pattern. So when we in the past, when we developed data loads one by each table, so they should look the same, but often they didn't. So now you have one pattern for your data load, which is executed for each table the same, and it's, as a result, it's lowers the risk of errors. Kind of, or part of this pattern is also naming conventions. So you have one naming conventions which is used for all tables, and if you want to change your naming conventions, then you just have to adapt this in one single place in your pipeline, and not for each data load again and again and again. And last but not least, a result of those centralized information about your data loads is kind of a documentation and traceability, which is an important part of, for example, data governance. So you want to have an overview, which tables are we loading from which source to which destination. You have a central place for your documentation. This helps you in implementing data governance. Okay. One slide. Metadata-based pipelines in ADF and Synapse are great. There are a lot of possibilities and also levels of complexity which we can achieve. So they are quite broad. So one hint on this stage is, don't over-engineer your solution. So I know we're all tech guys, and we like tricky solutions where we can put all our knowledge into it. But if you make one solution to cover all your tasks and all your edge cases, that can become difficult to maintain and to understand, also for your colleagues when they have to maintain the solution during your holidays. So you should focus on your main cases, your standard tasks, and you can develop additional individual solutions for your edge cases. So remember, your solution should save you time on development and maintenance, and should not produce additional effort for you in your daily work. One sentence to Fabric. So the one question we often get is, does the metadata-based pipeline from Azure Data Factory still work in Fabric? So the answer is yes, but there are some limitations yet. So there is for now there is no support for a self-hosted integration runtime yet when it comes to loading data from your on-premises data sources. And also the templates which I showed in the beginning are not available yet. So not if you're using pipelines for loading Azure-based data sources, then it works quite well. When you're using it for your on-premises data, then the self-hosted integration runtime is still missing, but it should come in the next month. Okay. Are there any questions so far?
Yes, there is. one of the big things that I know that I've worked with in the past, the way you had the SQL query being passed from a table into the pipeline,
Hmm.
would that or could that be seen as leading to SQL injection?
Yes, that's in this simple example, it wasn't that, but sure, you have to make sure that that's not the case, so that not leads to the injection. That's right.
Perfect. Yeah, I know I've worked with a few people who are like, I don't want to see any full SQL statements in my query ever, in my tables ever. So it's just one of the
Yeah,
things you
but
do
that
have to be aware of
this.
as you're playing. All good
Mm.
though. And also, Bala asked, what about error handling? ETL flow can fail at any activity. Your presentation assumes that every activity is going to work fine as expected. Do you, in your real thing that you work out there, do you have any actual error handling?
Yeah, in our customer projects, we add when we go to the in the pipelines, you can add an on-fail path, and so it isn't done in that example, but can add different tasks to do the error handling when it goes to this. So that's not in the example, not in the demo, but that should be in the real world when you do that, and add additional tasks for the error handling on fail or on completion.
Perfect. That is all the questions we have. So continue on.
Okay, thank you. Okay, as I mentioned before, on the one hand, we can develop our solutions by custom solutions, or build that in Azure Data Factory or Synapse in our custom pipelines. On the other hand, there are also some or many tools which are created for supporting you in develop your data warehouse, which are also using the concept of a central metadata data store, and they're using this data store to develop, to maintain, and to execute your metadata-driven ETL processes. So these tools should reduce complexity, and they're often using a low-code or no-code approach to enable data engineers to easily maintain their data loads. So it's also a way to enable some colleagues of you which are maybe less experienced in this data world and this ETL processes, and this lowers the threshold, or the lowers the complexity for those data engineers. So some examples for such tools. We developed a tool called CUBIdo more than 10 years ago, which was focused on the on-premise world, which is, yeah, a simple but effective solution. And the idea was the same. We have a central maintenance table or maintenance database where we store our informations from the source table, source schema, which groups, load scopes we have from source to destination, define the table mappings, define the column mappings, define some pre and post copy scripts, and all of that is maintained by a design application. And to execute those data loads, you just have to use a custom component for SQL Server integration services. So all the logic, all the information is stored in a central data store, and in the SSIS package. Just have to execute one task, which is configured, for example, load all of my sales data for this task. Unfortunately, this tool didn't made it to the cloud world, to the Azure world, so it's didn't develop it further. And nowadays there are also some other tools, and one example, there are many tools in the market for sure. One tool I know and we're using in our customer projects is TimeXtender, which is a tool for data integration, to connect different data sources, load them into an operational data exchange. It can be a database or a data lake. Then model a modern data warehouse structure, model your informations, and on top of that, build semantic models. And at the end, provide those data, those analytic data or semantic models to different endpoints like Power BI, like Qlik, or like Tableau. All of that is also based on metadata, which is controlled and maintained by a designer. And again, because we have all based on metadata, we have some additional advantages regarding documentation, regarding data lineage. For example, you want to know, hey, this KPI in my semantic model, from which data sources is it coming, or which processing steps we have done it before to get to those KPI. So that's all in this application. And yeah, this can be on different architectures and different technologies. It can be on-prem or it can be in the cloud. So that's again an advantage of metadata-based ETL processes, because the logic, the information is in your central data store, and on top of that, or on basis of that, you do your data loads. Okay, so just a few words, and I just want you a short overview or the possibility how it look like in application crashed, sorry. Just start it again. Here we are. So let's open our environment. As I said, we have an ODX, an operational data exchange, where we are kind of staging area where we have an overview about our different data sources. We have a data warehouse where we have different tables, and at the end we have a semantic model which is provided to Power BI. For our data sources, let's switch back to the browser. Those data sources are defined in the central portal, where you can define the connection to our different data sources. If it's a SQL server, is it a REST API, is it an Excel file, and so on. So we have one place where all those credentials are stored. And this also means the guy who is developing the data flow or the semantic model doesn't have to know, for example, the credentials or the password for those data sources. So that's can also split up the rights and security issues on that. So we have defined our data source connections, and for now we have we want to enlarge or enhance our Power BI dashboard. So for example, this is a Power BI dashboard which has one source, AdventureWorks 2019, some sales data based on the sales data from the AdventureWorks, and now we want to add some additional data sources. Go back to the TimeXtender designer, and now we add some data source, AdventureWorks 2022. I've already defined this connection in our portal. Just take all tables. Yes, I want to do a transfer task. Okay, and so also do the transfer. So the synchronize means he gets the metadata of all the information about from the source system, and the transfer task actually transfer or load the data from our source system to the ODX, which is in that case an Azure Data Lake. And second data source is we want to retrieve data from a REST API for our exchange rates. Okay. So again, do the transfer. Just still running. In the meantime, we can also do, for example, have different possibilities. For example, you can also define, instead of a full load, you can define an incremental load on that. So that's all possible, but we have to look on the time. When it comes to, hey, now we have our additional table in the ODX. Now we want to use them in our data warehouse. So let's search them, and now we want to adapt our data warehouse, which contains product data and sales order data. So we want to map the product from the new AdventureWorks to the existing one and do smart synchronize. See, hey, this weight isn't mapped for now, so hey, that's again product model. Okay, and one other thing is for the sales order, we have also define a mapping set, which is kind of logic. Hey, when it's something looks familiar to you. For example, hey, there's a new table called sales order header. You want to add them to your mapping. Then hey, do this automatically. Name for that. Okay, so now we have the new data for exchange rates. Let's just add the information for our exchange rates there. Just to speed it up, map the currency to relation and make a lookup on that. So we have the exchange rate in our data warehouse. All information is stored in the central data store, and now we want to add maybe a new field, which is called line total in euro. So go to field transformation, add one, and now we can, for example, make a formula. So it's just not only drag and drop, you can also add your formula for that. So see there's a mapping. Hey, all those fields are mapped to my metadata store. So when I apply that, and you see how when, for example, change, hey, that's I want to adapt this field, then doesn't result in an error in my calculation. It's also maintained there. Okay. Just save our changes and speed up because we're running out of time. Edit. All right, let's contract and line total euro. So we also have source control and work tabs in that. And all we have to do to bring that new information and new columns and new data to our data warehouse is to deploy and execute my changes. So just this, wait up, sorry. So in the background, now all the source code is generated. We do not have to implement those solutions on our own. We have the possibility to maintain this information in our designer, and in the background, all this information is all those pipelines and this logic and the technical stuff is generated in the background to our data warehouse database, and we do not have to know to write how to write the query to do the joins to generate new tables, to generate new columns. And yeah, so also people who are not that experienced or not that deep into the tech stuff can work with that. And for example, in one customer project, even the CFO is maintaining their data warehouse, building some semantic models on this data, and creating their own Power BI data sets based on this tool. Okay. Unfortunately, we are running out of time. Do we have some? How many minutes we have left, Kevin?
We have 15 minutes left.
Okay. So I thought we are finishing on 7 p.m. 1 p.m. It's on your side. Okay, then just finish demo. So yeah, this takes some time because it's also serverless bullet. Have to wake up. So in the background, he's deploying all the changes to our data warehouse and do the data loads. And yeah, so also covered with logging, and TimeXtender also promises that is self-optimizing itself in this process when you're doing on and on. So, it's finished. So next step, we have our semantic model, which is pointed to a Power BI environment. And all we have to do now is, hey, put also this line total to our sales order detail. Just some configuration. One thing I did wrong. So say that's a currency in euro. Should summarize it. Okay. Just once again. Deploy and execute. So now we have added also the line total in euro as a new field in our Power BI data set. As you can see here, we're also, besides the information which comes from the AdventureWorks tables, we have also a time dimension, which is automatically created by the tool. So we have it here, and it is also used in a semantic model, also with role-playing dimensions for example, for ship date and for order date. So let's wait some seconds for the deployment and execution of our ODX tasks. the meantime, as I mentioned, there are not only deployed to Power BI. There are different types of endpoints for the semantic models. As I mentioned, also Tableau and Click. So again, the advantage, you have stored your informations in a central data store. You have your logic in the semantic model, and you can now deploy, for example, those informations for the sales data to Power BI and also to Click and to Tableau. Same logic, do not have to recreate all those informations in a different development tool. Create this logic one time and then deploy it to multiple endpoints. Deploying it to our Power BI environment, and when we okay, let's switch to our report, and when we click refresh, oh, then we have our new data source here. Now we want to add our new column, which we have added here. Change that. Hey. So now we have added 2 new data sources to our data warehouse, created a calculated column, and provided that new column in our Power BI dataset, and our financial dashboard is now up to date. So enough for the demo of TimeXtender. So in general, advantages of a tool-based approach. As I said, there are many tools in the market. TimeXtender is one of that. This low-code or no-code approach lowers the threshold for your colleagues, for maybe less experienced colleagues to entering ETL project, to get an overview in the current situation, the current data landscape. It helps you for an end-to-end integration from the data source right through the semantic models. And it should accelerate your development, accelerate time to value. Also, the documentation is up to date every time. So normally when you write your documentation about the data warehouse in a Word document or something like that, it's outdated at the end of the day, I guess. So every time you're changing something, the documentation isn't that updated anymore. So in that case, the tool generates the documentation based on the metadata, and you can always have a most up-to-date documentation. And one advantage is to easily adapt to new technology, to new infrastructure without the need for rebuilding your solution. So when you want to change for using an on-premise environment and then want to change to an Azure environment or cloud infrastructure, then just have to redeploy your solution to a different target infrastructure, and all the work you have done before isn't lost. It's just in a different technology, and the logic itself is still there. Okay, at the end, some key takeaways. I encourage you to use the metadata-based ETL approach for to scale your data loads, to avoid redoing all the work again and again for each table, for introducing patterns, naming conventions in your development, and as a result, you should there should be a reduction of errors. The risk of error is reduced, and on the other hand, transparency, maintainability, all this documentation stuff is increased. And as I said, not also for the tools, for the tool-based approach, also when you develop the pipelines on your own, it should lower the threshold for new data engineers to enter a project, to get an overview, and to be able to maintain those solutions. As I said, on the one hand, you can develop your individual pipelines in ADF, in Synapse, in Fabric, when you have enough skills and when you have the ability to develop those pipelines on your own. For example, especially when it comes to complex use cases, to your edge cases to solve, then it's often better to make individual development in your tool of choice. But you can also consider the using of a tool-based approach when you want to, reduce the need of coding for the low-code approach, and reduce some complexity. Of course, tools are often not for free. There comes with licensing costs, and you have to consider and to make a kind of trade-off. Is it worthy to use a tool which maybe saves me some time or enables some colleagues to enter a project which were not able to handle those more complex individual pipelines, or do I have enough experienced employees which can handle those complexity? So it's not, a tool is not always the right the best choice, but it often helps to do all the work we have to do, all the workload. I guess also in the US, it's not easy to not that easy to find new employees, skilled employees for your data engineering tasks. So yeah, the tool-based approach is maybe the right one for you if you have a lack of data engineers and you want to speed up your development. With that, I'm finished. Are there any questions?
We do have a few. There have been some lively discussions back and forth on the actual table that we were talking about earlier for that had all the SQL statements in it. Where do you figure out the order of those, or how do you figure out the order of what is run at what time, or if it can be run at the same time? Or is there anything in your query at the moment that will allow for that?
Was it on the TimeXtender stuff or the pipeline? Order. Just have a look at the chat. The ADF pipeline.
This one with the ADF pipeline is the
okay. In that case, it's in that example there wasn't any ordering. You can implement that with a multi-level approach. Then you'd have put the ordering and the order information in the control table, so it can define those ordering in the control table. It wasn't in the demo yet, so yeah.
awesome.
But
okay.
this is has to be implemented in the pipeline.
Right. Okay, cool. All good. Does this approach support updating Delta files in ADLS, in ADF or Synapse without using the mapping data flow?
In the Delta files, to be honest, I haven't implemented it yet, but it should be possible. So maybe I have to ask one colleague if it's done yet, but it haven't implemented yet in Delta files, to be honest.
Okay, all good. And that looks like, Bala states that the lookup activity has a limitation of 5,000 rows. How do you overcome that limitation in your pipeline?
It has a limitation on
the lookup activity.
Okay, 5,000 rows. To be honest, I haven't one solution where it exceeds this limitation. Especially when you load not all of your staging data at once. So most of the time there are put in packages or different load scopes. So yes, this is a limitation that you're right, but I haven't reached that limit yet. So wasn't the problem yet, but thank you for the hint. Yeah.
Okay, that's what our people are good for, finding limitations. Cool, and I think that is all of them, because everything else actually talked about the order.
Okay.
And I think you've covered that pretty well.
Okay.
So I think we're good.
Because we're at the end, thank you for your intention. Thank you for having me, for inviting me to this user group. If there are any questions afterwards, feel free to contact me by email or LinkedIn. And yeah, that's for now for me.
Perfect. Thank you so much, Bernhard, for making this happen. This has actually been very helpful. I think since with the amount of questions people have asked, I am sure people have been thinking about how this will work. So yeah, I think this is great. And like you said, if anyone has any questions, please be sure to reach out to him on email or LinkedIn. So with that, just want to remind everyone that we do have another presentation coming up next week. 3 types of low-code Power BI Microsoft Fabric extensions with Power Apps on January 18th. So feel free to show up and have some more great questions and more lively discussions.
Yeah.
All right. So with that,
have a nice day.
You as well. And we will